Hey guys, we are going to do some STAAR practice because we are almost there. We have almost reached time to take the STAAR. So I wanted to give us a little bit of practice with problems where it's where you would use a proportion. Okay, so I want you to write this down somewhere, even if you do not have this exact example, which actually is better for you if you do not have a copy of this, because for the real STAAR, you have to do everything on your own paper. Okay, so proportion, these are things that might tell you we're doing a proportion. If it says expect or predict, or if it's kind of leading us in that direction, okay, to make a prediction. Also, if we see words like sample and population, these are words that tell us that we might be doing a proportion. There's other words that are going to tell us about a proportion, but that might be in when we get with similar figures, okay? So I'm sure we will see that later this week. So number 1 says Vincent flipped 3 coins during a probability experiment. The outcomes of the first 40 trials are shown in the table. So guys, we have talked about there's theoretical probability and experimental probability. Experimental probability means we are going to use the data to come up with our probability, okay? So we have 40 trials listed here. If I add this, that's what I'm going to get. 17 plus 16, 33, 33 plus 7 is 40. So this says, based on the information in the table, how many of the next 120 trials will the outcome be exactly 2 of the coins showing heads? Okay, exactly 2 showing heads. So I have to have heads, heads. Okay. Now, in this problem, one thing I wish is that they used that word expect or predict, because they didn't do it. It says, based on the information, how many of the next 120 trials will the outcome be exactly 2? How many would we expect? How many would we expect? Okay. So here's what I would do. Okay. Read that problem. Read it by yourself. Now I'm going to start pulling what's important from this. I can tell you with probability, a total is always important, okay? Now the next thing that's important is this says exactly 2 heads. So when I look at this is the only one where it says 2 heads, okay? So when we flip the coin 3 times, we got heads, heads that many times, okay? So there's a couple ways of doing this. This is the way I'm going to choose to show you this, okay? Now, we know that we got heads how many times? We got it, heads, heads, we got it 16 times. 16 times out of 40. This, guys, is our experimental probability. So hopefully this part makes sense. This is what we're looking for out of this many times. That's a probability, specifically experimental probability. So I'm going to put HH here, because that's for heads, heads. This is our total. I'm going to put TWO, total whole original, okay? Even though this is not a percent. Now, we do not want, or I could even put total trials. That might make it easier for you. Whatever you think is going to make more sense to you, okay? Now, some of you can figure this out without me going any further, and you're going to think you're thinking a little differently, but you're really not, okay? So this is how many trials we did. We want to know for 120 trials, okay? So out of 120 trials, I want to know how many will be heads, heads, okay? Heads, 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 total trials, okay? They have to match, okay? Now, our job is to cross multiply, right? This is where some of us are making our mistake. Now, if you think this will make it easier, you can simplify this, okay? So I can divide this, for instance, I know I can divide the top and bottom by 2. I know I can divide the top and bottom by 4. I know I can divide the top and bottom by 8, correct? So if I wanted, I could simplify. So for instance, if I divided this by 4 and this by 4, sorry for that weird marking, I would get 4 out of 10, correct? That makes it easier for me to cross multiply, right? Because it's going to be smaller numbers. So if you understand what I just did, feel free to finish the problem from that point. If not, you might see something else. You might say, oh, well, 40 times 3 gives me 120. So I could do 16 times 3, and that gives me that number. Okay? If you see that, feel free. You're going to get the right answer. Okay? So I'm trying to show you multiple ways to make it easier for you to solve. Let's say you have no idea about any of that. Then you're going to multiply 120 times 16. So 0, 12, carry the 1, 7, hold my spot, 0, 2, 1, 0, 2, 9, 1. That goes on one side, correct? 1, 9, 2, 0. It doesn't matter which side. Officially, I like to, when I start here, this is where it would go, okay? On the other side, we have 40x, right? Some of you can get this far and then you tend to forget the rest, but I know you know what you're supposed to do, okay? Divide both sides by 40 so that I can get that variable by itself, okay? So I can cross that. If not, you can divide by 40. It doesn't matter. So your job is to divide 192 by 4, or do one of the other ways that I showed you to get this answer. This is what I need you to upload today. Okay. Number 2. A study of a population of 1,200 frogs, there's that word, revealed that 12 out of every 180 frogs in the population have spots. Okay, so 12 have spots. Now, hopefully right now you're seeing a ratio here. Okay, 12 out of 180. So 12 have spots out of all of the frogs. Based on the results of this study, how many frogs in the population do not have spots on their back? So I want to know how many do not have spots on their back. Okay? So, and we want to know in the population. So this, if I cross multiply, if I work with this right here, this is going to tell me spots. So I need to remember at the end that I want the ones that do not have spots. Most of the frogs out of this population, most of them don't have spots, right? Only 12 have spots of the 180. So the majority do not have spots. So I'm pretty sure these two are going to be an incorrect answer, okay? So what we're going to do is we're going to take it from here, and we're going to, like, remember here that somewhere we're probably going to need to subtract because this says not. So we'll talk about that momentarily. So what I do know is this was our sample, 12 out of 180, but there are 1,200 frogs in that population. So this is a total and this is a total. This is going to tell me the number of frogs that have spots, okay? Now, just like I told you before, if you want to, you can simplify this. Like, I know for sure both of these divide by 6, okay? If you don't want to do that, that's fine. But I can simplify this fraction before I try to cross multiply, okay? This one right here. So, but let's say you don't see that. 1,200 times 12, okay? 0, 0, and I know I'm going fast. I hope that you take the time and maybe pause this and do it yourself. Hold my spot. 0, 0, 2, 1. Double checking my work there. Okay, so on one side I have 1, 4, 4, 0, 0. On the other side I have 180x. Now divide by 180. Okay, so your job is to divide 1, 4, 4, 0 divided by 18. Okay, that's going to tell us how many have spots. Okay, won't go into 1, won't go into 14. 18 times what goes into 140? I'm going to guess that I don't know. 48, carry the 4. 6 plus 4, 10, definitely bigger. Let's try 18 times 8. 64. 8 plus 6, ooh, perfect. So 8, 1, 4, 4. 18 into 0, 0. So 80. Good thing I already crossed this off, and I know that's not the correct answer, right? Because 80 of the frogs in that population will have spots. So your job is to subtract 1,200. This is the total frogs. 80 have spots. Your job is to figure out how many do not have spots. So I want you to subtract that and circle the right answer.